All right, this is a video to help you retake the target 2A, which says I can determine the leading coefficient, degree, and constant term of polynomial functions. You do need all of this information to master 2D as well, which is the graphing one. So this is an important one to review if you need to retake either of those targets. All right, so first things that I noticed that is a good clarification is that we should define the word coefficient. Coefficient is just a fancy word for number. So when I ask for a leading coefficient, which is the next definition, you should have solely a number as your answer. This number can either be positive or negative or zero. Well, only on the constant term. It's really only positive or negative for coefficients, because if it's zero, it's not present. All right, which then lets us go to the leading coefficient, which is not the one in front. That is definitely a misleading bit. It's just the one attached to the degree. So it is a number multiplying with the degree. And again, it cannot be zero. It could be for this one, because if it's a zero, it goes away, because 0 times anything is 0. It can be positive or negative. And I would say that the negative is the emphasis of this video, because students would get the correct absolute value of a number, but they would not write negative, and that would be incorrect. You don't really want to ever have negative money, so it's a good way to remember it that way. Constant term. This often is easiest remembered as the no variable, which I've always given you as x term. It can be 0 here, which is typically going to be when it's absent. Let's see. The last one is degree. Degree has, let's call it 2 different definitions. We have the standard form, which is something like I know you guys hated seeing it, but it's just a way to represent that it's in descending order. Oops, forgot. There we go. We'll just do a couple more. This is just standard form. An example, we'll follow it up right behind it, would be something like, come on, change colors. 3x to the 4th minus 2x cubed plus x squared minus 11x plus 12. This is just standard form. The degree, the definition for it in this instance, would be the highest exponent. And so the reason we call it leading coefficient, to circle back to the beginning, is because it should be the very first number we see. However, I, of course, try to trick you on these problems, because I'm asking you to inspect the entire thing. Not everything is always organized, and so you do need to be able to recognize it in multiple forms. I would say that the other definition comes from factored form. And this is how you would be able to get the A, or the full mastery on this target, and it's coming from factored form and the fundamental theorem of algebra. Fundamental theorem of algebra, which is basically the entire premise of the test. Do you understand that degree ties into the number of zeros? Degree is the exact number of zeros in a polynomial function. So how this helps us in factored form is factored form allows us to count the number of factors present, including multiplicity. Oops. Including multiplicity. Remember, multiplicity is basically the repeat in, I guess that's one more we should define. Multiplicity, a repeat of the same factor. Okay, so this is just all the definitions that I believe that you should have in your notebook. We started out pre-strike time, pretty much defining these almost every time we saw one another, so it's really important that you know these. But let's get into an example where we can see them all in play, especially with the factored form. Okay, so here's an example. Okay, and let's get another example down here in factored form. Okay, so, you know what, I'm gonna sneak back in here because I can. In this very first one, remember where our first question is are we in standard form? So we want to take a look and inspect all of the exponents. So we are comparing the exponents. They are not biggest to smallest. So it's not standard form. However, it could be rearranged to be in standard form. And we honestly don't really need to physically rearrange them. At this point, I think we can identify what the degree is because we define degree in standard form to be the highest exponent. So this would be fifth degree because 5 is greater than 4, which is also greater than 2. So fifth is the answer for degree. As I inspected all of the exponents, I'm taking the largest. Now, that helps us find the leading coefficient because the leading coefficient is the number multiplying with the degree. So as we found the degree, we can pop right in front of it and find the leading coefficient. Lastly, the constant is the no variable one, and I can see that at the end that there is no x, and so our constant is negative 11. So it's just typically that you didn't have the correct definitions or you accidentally forgot to pay attention to the negative sign in front of the number. Now, I would say that the most commonly missed one is the example we have here. As you saw, I kind of snuck this last one in because it is very important that you understand that negative 3x is a factor. Remember, factors are things that multiply to be something. So this polynomial function, which we'll find out what degree it is in a minute, multiplies all together to be a polynomial. They have factors or things that multiply to do that. Now, negative 3x is the way that mathematicians write the factor. However, it really should be expressed as an addend. An addend is a binomial, if you will. It could be a trinomial. It's things adding together that also might have products. So we see this product, negative 3x, but really it's being added to a number as well, which is its individual constant term. It's invisible, and there's only one number that we can add that does not change the value, and it is 0. So the first step that you need to mentally think, or, physically rewrite as I'm doing now, is this step right here. It will ensure that you don't accidentally calculate the constant as something other than 0. Okay, so now the degree, I think, could be simple to count. I see 1, 2, 3, 4. But remember, you should be reminding yourself, don't forget multiplicity. And so again, this is another opportunity for you to be expanding more if you want, or most students will be like, oh, I need to come back in and add 5. So this is a 5th degree polynomial because there's 1, 2, 3, 4, 5. Or you could just double count. All right, leading coefficient is a little bit trickier. It requires us to either multiply the whole thing out, which sounds like a lot of work, or just really ask ourselves, where does the leading coefficient pop up in a standard form polynomial? As we can kind of go back to the beginning, we know that the leading coefficient is in front of the degree. And from our basic understanding of just two binomials foiling together, FOIL, right? I mentioned FOIL a lot. F stands for firsts. And so if I'm looking at these two pairs right here, because they're just conveniently next to each other, if I were to do the firsts, I would be doing the degrees of each binomial. The degree of 3 minus 2x is 1, so then minus 2x. It's the highest power of x. This is the first. It will multiply with x. So every single time, all of these firsts are going to multiply together. So we can just ignore the x and take the number, since leading coefficient is only a number. So I plop down my parentheses just like I see them in the problem. I have my first set, second, third, with an exponent. So my first, second, third with an exponent, and my last. I'm going to pull each of the leading coefficients. So I see my first leading coefficient is -3. I have to kind of skip to the x here and take the -2. Anytime I just have x, the number in front is either 1 or -1, dependent on the sign. And then my last one is 8. And so now I can put that straight in the calculator. Of course, I could just kind of show my work real quick. I get -3 times -2, that's 6, times 1, and times 8. So I have a leading coefficient of 48. Lastly, the constant is now a little bit simpler because we have represented who's missing. So I'm going to do the exact same thing. Parentheses, parentheses, parentheses squared, parentheses. But this time, I want to pull all of the constants of each binomial. And remember, we rewrote the very first one to be 0. So I'm going to pull all of these numbers in. And of course, you might be like, well, 0 times anything is 0. And you might have already written that down. But just for viewers at home, we'll just kind of work through this. Well, that's 0 times 16 times -3. Well, that's 0 times -3. Well, 0. Okay? And it kind of makes sense because if you were to ignore, let's say we ignored this piece right here and multiplied it last, you would get a whole long 4th degree polynomial for this, which has a constant term. And then we are going to multiply every term, including the constant, by -3x. Well, everything is growing by a power of x, including the constant, thus making the constant no longer visible. And when we don't have a visible constant, it again is 0. So my thought is I will put a little this video will be on Canvas, obviously, where you found it. And then please go, there's a little checklist on how you can double check to see if you're doing this right before you take the retake. You only get one retake.